So once again, we'll start about 4 minutes after the hour, giving people time to join. There's still a few clicking in, I see. Okay, it is 4 minutes after the hour. Don't want to keep everyone else waiting too long for those joining late. I am Phil Ritter, and I want to welcome everyone to our monthly Magma 5G Ask Me Anything, everything you need to know call. We're doing this series as an introduction as we prepare to formally launch the 5G release of Magma, which is getting very, very close, and we'll talk about that today. And we'll also be talking about some things we're doing about integrating it with other uh, LF-based projects as we've moved to our alignment with the Linux Foundation. Uh, I am the community manager for the Magma 5G or the Magma project, the open source project through the Magma Core Foundation. Hosting this morning, Kader Khan from Wave Labs is with us today. I'll let him introduce the agenda and then get right to it. Kader.
Thank you very much, Phil. Thank you for that warm welcome. Thank you once again for everyone taking time this morning to support us with this great initiative of this Magma community. Just a quick refresher. I just wanted to share with you why we are having this meeting. It's no brainer, right? 5G is a great opportunity for all of us. And what we have been seeing is rise in adoption of Magma 5G in both community projects as well as the commercial 5G projects. Just to give you an example on the community project, Elephant 5G Super Blueprint. So within the community, among the stakeholders, we really felt that we require a dedicated platform to support enabling engagement, collaboration, and adoption of Magma for 5G. So, here we are today again with the three key objectives. So the first objective is we as a community wanted to ensure, everyone has a good understanding of the ongoing and future 5G development activities. And the second key objective is we wanted to help enabling Magma community from the Magma community, the collaboration and alignment with other community projects, like I mentioned, such as Elephant 5G Super Blueprint and other project that uses Magma for 5G. And finally, we all wanted to learn together, share and support each other in the community with demos, integrations, and so on, right? Again, the goal is to really advance the adoption of Magma for 5G. As always, I like to really appreciate the feedback that you provide to us. Also, like to invite, thank you for attending. Also, would like to invite you as speakers for next sessions, and thanks to the speakers for this session. That agenda, Phil kind of already introduced it. Just to formalize it, we'll start with a quick development and support update, what we have been doing with respect to the 5G Magma, followed by Jared and Ankur will show us the testing progress with respect to the Magma 5G in action with real UEs and GNodeBs. And then we will have Yogendra from Arna Networks and their work in integrating Magma with their AMCOP product. for lifecycle management, orchestration, and some good stuff there. And finally, we'll close with the Q&A. That's going to be our agenda for today. So with that, without further ado, I'd like to invite Suresh to give us a quick update on 5G SA development. Suresh, floor to you. You have 3 to 5 minutes, please.
Yes, thanks, Kader. So this is a information to all the Magma community members as well as the Linux Foundation. We have code available in Magma master branch for the features UE registration, deregistration, and then you can try all the service request handling, so both signaling mode and data mode features are also available. And the basic authentication is available as of now. However, our plan is to add full-blown authentication vectors sometime in the near future. So with these basic features in the system test environment, using real UE, we are able to browse internet via this 5G core network product. So currently, with these features, some hardening effort is going on. We have a few bugs filed from system test, and also as part of hardening exercise, we are also trying some scale tests. So we are stabilizing the product sometime soon. These features will become even more stable. And in addition to that, the negative scenarios also are handled. Say the cause, mobility management causes, and SM causes also made it to the master branch, whereas these are not yet rigorously tested using the simulation environments. So that is a small part due on the negative scenarios part. And the features that are planned to be available in Q4, the important ones, say the 5G QoS and dynamic policy support, and then some level of reporting, monitoring, and multi-session support. These are planned for Q4. As such, reporting and monitoring is already there in Magma as part of the 4G implementation. So plan is to add extensions to support 5G related reporting and monitoring. That's the update on the development side. Kader, Q&A, do we take now, or do we postpone it to later time?
We are good, Suresh. Thank you very, very much for the quick development update. Moving on, just a quick update on the support. There's been a lot of Q&As going on, a lot of videos, how to do a lot of different things with 5G. I really invite you to, collaborate with the community members in the Slack channel. And we also have a free orchestrator that's hosted in AWS that is available for the Magma community to use and play around the early implementation of 5G and with their use cases and within their environment that they wanted to use. So please take benefit of both the Slack channel as well as the orchestrator that is available for the community to learn and also increase the adoption of Magma for 5G. So with that, I'd like to invite Jared and Ankur to take the floor and help us learn testing 5G in action with commercial UE and GNodeB. Jared, do you want to share the screen?
Yeah, sure. Actually, Ankur, are you going to share, and I'll talk through the first bit and then pass it over.
Thank you. Let me stop the share here.
Okay.
Yeah, floor is yours.
You guys, can you see the slides?
Yep, we got it. Awesome. Cool. Thanks, everyone. I'm Jared Mullane, and this is my esteemed colleague here, Ankur. We're both on the Facebook side supporting Magma, and our team focuses heavily on the testing and validation of the Magma product. Slide. So today we're going to go over a couple different things. I'm just going to give a little bit of background as to why the reasoning behind why we wanted to set up a 5G lab. Then I'll pass it over to Ankur. He's going to give a overview of kind of the infrastructure we've set up and the architecture that we have currently in our lab. He's going to walk everyone through a 5G call setup and then go over a PCAP trace and then kind of go over our next steps and kind of what's on our roadmap in terms of improving our current lab setup. Cool. So similar to Magma 4G, we wanted to create a physical setup to validate the performance of 5G. So that required us ordering and installing a new physical test setup. We recently ordered all this equipment to set up this end-to-end test lab. And then we wanted to integrate Magma with commercial off-the-shelf hardware. And so through our partnerships and work with Wave Labs, we've recently constructed our lab using BiCell's equipment for the G-Node B and the other components. And we successfully brought up our first call. In the next quarter, we're going to continue to invest in this infrastructure to make it better, more robust, more dynamic. So this includes stuff like integrating it with Spirent software to be able to conduct scale tests. And then also with our hardware in the loop infrastructure to provide real-time feedback for everyone as to the performance of the end-to-end setup. And then our plans are to share this more broadly with the Magma community, so everyone will have access and visibility into the performance of this. And so then people can reach either Ankur or myself with any questions around the test cases or performance in general. But now I'll kick it over to Ankur, and he's going to walk everyone through what our lab setup consists of in terms of hardware and architecture, and then give a quick demo of the 5G call setup.
Thanks, Jared. My name is Ankur, and I will be going over the lab setup we have for testing Magma. I have a few slides, but mostly it will be around a great demo for a 5G call setup on a BiCell equipment. So my objective is to cover like how what physical equipment we are using in the lab, and we have a demo, and just chiming into like what is the hardware in the loop and what are some of the scale strategies we will be adopting to test this integration at scale. So as you know, Magma is evolving, and 5G feature sets are being added pretty much every single day. So the intent of this particular presentation is to show everybody how we have integrated Magma with actual physical equipment and what are the different physical equipment which we are using in the lab. So if everybody can see my screen, this is the journal we have. G-Node B from BiCells. Our access gateway is a general purpose off-the-shelf hardware, which is, if you can see.
Ankur, sorry, I would kindly request attendees to mute yourself so that we can have the smooth presentation and we all can hear Ankur, please. Thank you very much. Ankur, please.
Is that better?
Yeah, there's some noise coming from, I don't know this, is it from you or from others? I have requested others to mute, but please move forward. Yeah.
Okay, all right. Yeah, so we have this access gateway, which is off the shelf. Like it has like 8 gigs of RAM and like a 4-core CPU, which is running the 5G code. And from the G-Node B side, we have a BiCell G-Node B, which radiates in band 78. And basically, if you can see on the screen, like we have these antenna ports going in the RF chamber where the UE is usually put so that it can connect, get the signal and connect to the network. For G-Node B, like as the RAN is like disaggregated, it's an open RAN infrastructure. So we are also using a CUD from BiCell that connect to our G-Node B to bring up F1 AP and NG-AP. And from the UE side, we are currently using a Huawei Mate 30. And one of the things which we have to do in order to bring up this setup is definitely provision our subscribers. And to provision our subscribers, we have to burn a SIM card with the actual like K values or PLM and ID tag information. So we are using a bunch of blank SIM cards, and we use a SIM card burner, which is available from Amazon. And that's how we set up our this particular environment. So now let me show you how a call flow, I have a demo of this UE going from an idle to active mode, and I am basically trying to ping through the UE, and you will see a live packet capture. Let me make sure this. So let me explain, so for the UE, we are using an app called Visor, which basically gives us the remote capability to control the UE. And that's what you're seeing on my left hand side. Right now on the top, as you can see, there is no network connected. And here I'm trying to do a live capture on the NGAP side. So I'll filter the protocol stack to NGAP. As you can see right now on the top, it says emergency calling. As soon as the UE scans band 78, you can see the call comes up right away. On the top, you can see there's FB network. And this is exactly the protocol stack that looks like when you do a packet capture for a 5G call. So this, like you can see, like, so like on a very high level, like .35 is our AMF and .30 is the CUIP. So you can see those protocol exchange going between two different entities, going all the way to the PDU session accept. Once we have the IP in the PDU session accept, I can, from the UE, I can start browsing. Here, what I'm trying to do is like trying to ping facebook.com. So I'm just using a app that does the ping, and I'll filter this GTP like packet capture for GTP messages also, and we will see some DNS queries and then ping ICP packets going through. Okay, I'll pause over here. As you can see, like on the UE side, especially over here, like you can see a GTP packet going for a DNS query. .254 is the IP of the UE, which is basically querying like a DNS for facebook.com. And once it gets the IP ending in 11.35, it basically sends the packets out. Like you can see request reply packets going through. And on the UE side also, you can see the actual IP of which it got by DNS query, like ending in 11.35, which we see on the packet capture. So as you can see, like, the Magma stack actually physical and after this, I also have so here is a PCAP trace from the same session, just like, highlighting different control plane messages going between the AMF and the CUDU unit, and some of the DNS queries coming from the UE side of the house. So yeah, so as you can see, like, in this setup, like, we have used like a physical setup to test out functionality. And currently, like, like for our Q4 roadmap, our plan is to make sure, like, 5G, we have 6 test cases for testing out call flow on a physical setup before the launch. And these test cases go around like setting up NGAP messages or F1 side of the house, initial context setup, video coming up, idle or paging. So these are the things which we want to test out on physical equipment and make sure it is 100% compatible. And as we grow and build more features, so we definitely need some kind of a like a scaled environment to test out what would be the performance of this setup on a like a scaled environment, like maybe what is the performance looking like for 100 subscribers, what's the throughput looking like for like 200 subscribers. So for that, we are building up like this span test bed, which will be used for our uh, uh, like scale testing. And along with that, like, we want to make sure we have a good signal when the code is landed. So we will be integrating this with hardware in the loop. Basically, hardware in the loop does a couple of checks. As soon as the code is committed and we build an image, the new image will be deployed on these access gateways, and there will be a portfolio of test cases that will be run in the future that will encompass like sanity, like is the control plane coming up, right? Then it will be like some cases will be like around throughput testing, some cases will be like around availability testing, and some cases will be around soap testing, like how's the long-term performance of 5G looks like if we keep the test case running for maybe 48 hours or maybe 1 week, kind of a thing. So this would be our strategy, like, which we want to implement going forward. And I would love to take any questions if you have for this particular setup.
Thank you, Ankur. Thanks a lot. We appreciate you sharing the questions in the chat. We'll take them towards the end of the session. I just want to make sure that we give enough floor for our next speaker, Yogendra from Arna Networks. Please take it away.
Yeah, sure. Can I share my screen now? Okay.
Please, yeah. Feel free to please post your questions. Like to hear more questions from you.
Okay, so I have this already pre-recorded demo and with the voiceover on top of it. So directly I'm going to play that, and then probably at the end we can take up all the questions. Okay.
Hi, so today in this video, we will be doing Magma deployment using AMCOP and managing both orchestrator and access gateway remotely with the help of AMCOP. So as a deployment strategy, we look forward to use AMCOP and Magma controller placed centrally in some sort of cloud provider, DK, AWS or Azure, whereas the sites at edge would be running Magma access gateway, which essentially would be managed by AMCOP itself, along with some of the other cloud native applications running locally at those edge interfaces, where AMCOP would be responsible for managing the deployment itself using Kubernetes API, deploying Magma controller on the local cluster itself, and Magma access gateway on the remote cluster, interfacing with the Magma controller using REST interface, using which we would be triggering the registration request for access gateways that has been deployed using AMCOP. And another interface potentially we can have with the Magma access gateway to fetch the hardware ID and challenge key, unless it starts providing a mechanism where we can pre-program hardware ID and challenge key as part of the deployment itself. So from a registration prospect and the required configuration, we assume Magma controller is already deployed with the relevant certificate, and the CPA has been created, providing the admin key for certain key for operator. Then followed by an access gateway wortlet is provisioned with the required config and certs as part of day zero configuration. Hardware ID and challenge key can be fetched as once the deployment is done, which results in triggering the CPA, doing config assign and config deploy, further merging the config templates and parameters, forming the relevant AGW registration request, which is further sent to Magma controller over the REST interface to essentially program the access gateway in the controller. after which the access gateway can check in into Magma controller and initiate the bootstrap process. So since this is still work in progress, so we will be showcasing today the deployment part only, where we will be deploying the Magma controller and access gateway with the day zero configuration, and the portion of automation of AGW registration is not yet available, so we would be triggering that manually. So switching to AMCOP UI, so we have two clusters. One is the host cluster and other is KUD cluster, which we will be using as a remote equivalent for deploying access gateway. And we will begin with creating the services and deploy the access gateway. So first of all, we will need SQL based databases that are consumed by orchestrator and orchestrator UI. So to simplify our deployment following the guide documented by Magma community, we would be using two separate databases, MySQL and PostgreSQL. Followed by creating a service for Magma controller, which will include help charts for orchestrator, and override profile that would be including the relevant information of certs that we will be using for this deployment, and all other overrides we want to potentially do. Then we will include LT extension on our orchestrator that we are going to use for this demonstration, and create all the three relevant services. Followed by, we would be spawning instances of these services, starting with SQL. So this is going to be on the host cluster. So let's create the instances before instantiating them. Followed by instance for Magma, which is also going to be on the host cluster. Okay, so all the service instances are created, and if we switch to the cluster, currently we do not have any pods. So we'll start creating the databases first. So both the SQL and Postgres SQL are being created. So let's instantiate Magma. Which is instantiated. We see the corresponding pods are being created. So with all the pods running now, we should have access to the NMS UI. This is the domain that we chose. So I'm logging to the master instance of this one. So this help chart by default creates the user as part of the deployment. So this is where So we'll continue using master instance, and I'll just enable NMS access. So if you see, we do not have any network configured. So we are starting with a blank slate. So we'll add a network first, network_1. And we are going to be using network type LTE. And however, do not have any access gateway yet. So we will begin with the access gateway creation as this is where we will upload the help chart for HW wordlet along with the override profile. And now we'll create the instance for this access gate. So this is going to be deployed on the KUD cluster emulating edge, and access gateway requires dual interface, one towards internet where we will be connecting to the Magma orchestrator, and second provider network providing connectivity to eNode P. So we have access gateway instantiated. So on the KUD cluster, we see the wordlet has been started. So we'll wait for access gateway to come up so we can fetch the hardware ID and challenge key to register it against the orchestrator. So in a couple of minutes, wordlet will be up and running. So this is where we will fetch the hardware ID and challenge key from let's call it wordlet gateway 1 hardware ID version. It will auto pick. And the challenge key. So we have the gateway created. So now, usually you would have proceeded with configuring the access gateway. So we don't have to do that because the configuration and the root CA certificates are loaded up front. So all we are going to do to monitor is whether the status of Magma check-in goes through fine. So we see that it has already bootstrapped successfully. And shortly the check-in should also go through fine. Yeah. So the check-in is also successful. And if you see the health is good, the last check-in has already been done. Right? And that concludes the demo.
Yeah, so that's all we had for the demo.
Thank you, Yogendra. Just a quick question around that, right? One of the questions that we have is, what you showed is the deployment, automated deployment. Is there any monitoring? What are your other plans, like lifecycle management and monitoring? Are you guys working on that direction, or what are your plans next with Magma?
Sriram, you want to take that, or shall I?
Yeah, sure. Hi, Kalar. This is Sriram. So I can take that question. So the first step is to complete the demo. In fact, what we've shown in the demo, there are some dotted lines there, right, where we can configure through the CDS. So that's the next part that we're going to do. So that will essentially automate the whole process, so that whatever manual steps that were shown in the demo will no longer be required. After that, there are two things that we can do. One is the lifecycle management. If there are any configurations that are required, like a day end configuration, we can do that while it's running. That's one. The second is sort of slightly more longer term is creating a closed loop. So if there are any events that we can receive and take some actions based on that, that's the next step that we want to do. So these are the two things: the day end configuration and the closed loop automation.
Okay. And you would depend on third-party tool to feed the data, or is this something that you're going to pull it directly from Magma and other components that you would manage, Sriram?
So Prometheus is one that we have done integration through Prometheus. So we haven't actually looked at what kind of data it natively generates. If there is there are ways that we can get the data through any of the means, like a WES or SNMP or any of those interfaces, we can consume that and use that data to take some decisions.
All right. Thank you. So feel free to unmute and ask questions while I read some of the questions in the chat. Continue reading it. So Ankur, the question to you is whether A Gateway is running on bare metal or VM.
So right now, in this particular setup, we had AGW running on a bare metal, but we do have virtual access gateways also.
Okay. And the second follow-on question to that is, the test setup that you're trying to do, hardware in a loop setup, right?
Mm-hmm.
Is it virtual or is it hardware-based?
It is actually hardware based. We want to make sure we get the exact signal because most of our partners are deploying on a physical access gateway. I can go in like what kind of testing we do on a virtual setup. One of the predominantly things which we test out is to the upgrade path when we do a release validation, because over there the resources can be spun up really fast and just make sure we can go from, like, let's say for example, Magma 1.5 version to 1.6 version. So those are the things where we leverage virtual access gateways. Some of the other things which we are leveraging virtual access gateways is around the scale testing, where we can scale the CPU cores and the memory and see what is the right combination. Like if instead of decentralized access gateway, if we have to combine the resources in one access gateway, how the performance would look like. So those are some of the use cases which are currently leveraging for virtual, but we are planning to use a virtual access gateway for other purposes as well.
So the testing basically includes both benchmarking both virtual, Magma, as well as, I'll put it as Magma instead of A Gateway, right?
Yes.
And the physical one. Okay.
Exactly.
Okay. And is there any reason why you use hardware-based simulators? Why not software-based simulators? Is there something that you can share?
Sorry, hardware-based simulators?
You said you have Spirent, right? So
yes.
it's a hardware-based hardware simulator, or is it a software virtual simulator? That's
Definitely, Spirent has two components. The traffic generator is a physical box, but like all the protocol stack, whether it's for 4G, 5G, or Wi-Fi, it's based on software.
Okay, understood. So just for the throughput stuff, you use the hardware-based.
So basically, it's a closed loop system. Yeah. So like in general, like how if we have to go Spirent route, how do we do it? We simulate all the RAN side sources and SGA internet side sources. So Spirent sits in the middle, right? So we spin up like up to like 100 200 UEs. It goes on the Spirent. So in the middle we have the access gateway, and basically when we loop around and go towards the internet, it is again going to Spirent, and Spirent is sending back the messages. So that's how we do a closed loop testing and do throughput and other benchmarking.
Understood. So there are other simulators are also used by the community members, right? Whether it's a vendor or SI. And can they use your framework and plug in their simulators, instead of Spirent simulators? That was another question.
Yeah, that's a great question. Actually, for when it comes to Magma specifically, we talk about like implementing standard stack. So it doesn't matter like which simulator you're using, as long as it's 3GPP compliant, it should be able to work with Magma.
And they can also leverage your hardware in a loop, CI/CD, whatever that you have built, to plug in the other simulators to do the continuous integration and continuous deployment testing.
So that we are building for the community. As of for now, it is not externally exposed, but we host that infrastructure in AWS. Not any. It's not hosted in Facebook environment. So we are trying to expose. What are the different knobs on the Magma itself. Actually, there is, if you go on the GitHub page, there is also a HIL badge. We make sure we tell the community like right over there, like whether this release, like if some PR lands, image is built, whether it's healthy or not.
Got it, understood. I have another question that's more related product. Apologies for that. The product that you use for your testing, I think it's about base cells. So they were asking is CU and DU is whatever that you procured from Basel, right? Is CU and DU comes with it, or is it like a separate product and the antenna is a separate product? How did you kind of brought this whole pieces together?
Yes, so it's another as we understand the Open RAN infrastructure, right? So when we got this equipment, it was part of the same build of materials, but it doesn't limit us just to using one radio. We can use a lot more radios with the same CUD unit.
Okay, got it. Any other questions from anyone? Please feel free to unmute and ask. Meanwhile, I'll continue reading the questions. So what about Federation Gateway? The Magma has a gateway, Federation Gateway, and orchestrator. What about Federation Gateway for 5G? I think that's more for you, Phil, I think. Phil? Anyone else can answer? What about Federation Gateway for 5G? Yeah.
Sorry about that. I was on mute. Right now, the Federation Gateway is focused on the 4G interfaces. And what we have done for 5G is a 5G SA configuration. So the Federation Gateway is not reasonably compatible with a 5G SA deployment. There are a couple of options that we have looked at for how we would deal with the Federation Gateway in a couple of cases for policy control, where we could bring policy into 5G through the Federation Gateway's 4G based interfaces. There's also the option of direct REST-based communication without the need for a Federation Gateway in the 5G SA services-based architecture. But right now we have not scoped those capabilities in to the Magma project. They are futures for us.
Understood. Thank you, Phil. There's a question, do we have anyone in the community running a gateway in ARM CPU? If anyone is doing it, please feel free to unmute and answer to Govindarajan, please. This question is coming from him.
Yeah, I can actually address that to some degree, Cotter. There are partners in the community who have ported the 4G product to ARM. Again, the 5G is new and hasn't been formally released as a product yet, so those ports have not occurred. However, given the way the product is architected and the fact that most of the code that implements the 5G capability is Python based or pretty simple standard where it is C or C++, the port should not be difficult, but I can't point to anyone who's done the port for 5G at this point.
Understood. Thank you, Phil. There's another question.
Govind here. Thanks, Phil. Can you share some of the people who are building ARM-based AGWs?
Yeah, I think the most effective way to do that would be to point you back to the conversations that have occurred in our Slack channel rather than me trying to pull from my somewhat old and failing memory specific pointers. There are a couple of ARM-focused channels available within the Slack, and you can see the folks that have done that. Plus, ARM is a premier member of the Magma Core Foundation and is really, really pushing and supporting those that are doing those ports. So I'm gonna take a punt a little bit on the question because I don't have a list of specific partners to point to, but it is publicly available in our open communications.
I know that information. I thought you may share more details about some other players who are into this. Yeah, so I'm aware of those people who are making products. Yeah, thanks.
I apologize. I just don't have anything prepared, and what I don't want to do more than anything else is misspeak.
Thank you, Phil. Go ahead. Maybe what you can do is you can send an email to me and Phil, and we can take this offline.
Perfect.
Sure.
Okay. There's a question, is there any hardware dependencies while running Magma 5G core, or can Magma run on any standard hardware or VM? Phil, Suresh, Ankur, please feel free to answer this question.
So right now,
at least it is hard to answer for me, Kathir, because the security algorithms, whether they have any Indian specific or architecture specific treatments are there, I'm not sure. Maybe Ankur may want to speak about it.
Yeah, just wanted to just chime in on the same thought. Like, right now we don't have a scale setup, and most of our testing was done on x86. So as long as if we follow the exact setup guide, we should be able to bring up an access gateway without any issues.
Understood. So this is more question for Yokesh and Sriram, you, right? The question is, in the product, the orchestration, whatever that you say that you're doing orchestration, can you a little bit elaborate what are all the things that are included into what you call it as a multi-cluster orchestration?
So the AMCOP is what we call. It essentially has, for the purpose of this demonstration, there are two main projects. So one is EMCO, EMCO. So EMCO actually started off in the ONAP as the ONAP for KADS project for orchestrating the containerized workloads on ONAP. And later it moved to Intel's openness project, and now it's actually a standalone project under NFN umbrella. So that's one project. And that's what is used to orchestrate the CNFs or VNFs in this case. The second one is a one-app project called CDS, Controller Design Studio. So that's the one that we use to do the configuration, the day-end configuration of the elements, the CNFs or VNFs. The third one, which we will use in future, is the DCAE related components in ONAP. And that's what we are going to be using for the closed loop that I mentioned, which is around that part of us.
Got it, got it. The third one is DCAE, use it for real-time monitoring and policy-driven control loop that you kind of said. Okay. The day one and day two is basically the lifecycle management, and orchestration is getting everything up and running as you showed in the demo today. Thanks for that clarification, Sriram. Any other? I think I have read all the questions on the chat. Okay, there's one more here.
I have one question, this question to Ankur and Philip maybe. So then when we say 5G Magma, right? So when you're exercising it, so the user is getting authenticated, correct? So which algorithm we are supporting in there, EAP AKA or EAP AKA Prime at this point of time? Because I was not able to, get it through from the documentation, so I thought probably I'll check with you guys.
That's a very specific question. Can we answer that confirm and answer that offline, perhaps?
Yeah.
So if you can drop an email to myself, we'll get a very specific answer, and we'll make sure that we find a way to communicate that back to the community too, so that it's not just limited to you.
Yeah, makes sense. Or maybe I can just post that question in the Slack channel itself. Yeah, that will be good idea.
Yeah, that actually may be a good way, because then all of the conversation will be open.
Yeah, thank you.
Just to add to that, I can also share the PCAP. Exactly, we can see what algorithms are being exchanged on the wire.
Yeah, awesome. That will be awesome. Yeah.
Right. I just wanted to thank Mark for posting the chat for those who asked about the ARM support to reach out to the project ARM support Slack channel. Thanks, Mark, for that. There is a question from Samit. I think this is again to Sriram and Yogendra, to you. What are all the closed loop operations that are being envisaged? Yeah, envisioned. Yeah.
So we haven't actually
Sriram, are you speaking?
Can you hear me?
Yeah,
oh, you're back.
You're back.
Okay, I'm sorry. So we haven't actually thought about any specific scenarios yet. So hopefully in the next few weeks we will we'll look at them and then we'll publish what we're thinking.
Right. Thank you. All right, so that brings to the end of most of the questions. If anyone else have any questions, please feel free to unmute and ask. Meanwhile, I would like to, myself and Phil would like to request you, if you are doing some projects within your organization and within your community and you wanted to share it with the community, feel free to reach out to Phil and me. We'll get you to speak in our next monthly meeting. And if you also know someone else interesting project that they are doing with Magma, feel free to refer to us. We'll be happy to get them on board here, have them to share what they are doing. It's a collective cooperative learning session where we can learn, share, and grow the adoption of Magma together as a community. That's a kind request on behalf of Magma Core Foundation as well as Linux Foundation networking teams here. So with that, Phil, I'm going to give you the honor to ask if there are any few questions left out and close the session, please.
Yeah, thanks, Kader. Last call for questions, and hearing none, on behalf of the Magma team and the Magma Core Foundation, I want to thank everyone for joining us, and really looking forward to seeing how Magma develops over the next few months as part of this community-led effort. So Thanks, everyone. Have a great day.
Thank you. Great event.
Thank you all.
Thank you.
Thank you.
Bye.